Hi everybody, Mrs. Pesek here. We are looking at section 4.6, graphs of other trig functions. Now this is really the part of the section, part 2 if you will, where we're going to learn how to graph tangent functions and cotangent functions. So the tangent function is odd, as we discussed earlier. So that means that the tangent of opposite of x is equal to the opposite of tangent of x. That means that tangent is going to be symmetric about which axis? Well, if it is an odd function, then it's symmetric about the origin. All right? And so you know that the formula for tangent of x is sine of x over cosine of x. That means that the tangent function is going to be undefined whenever our denominator is equal to 0. So whenever cosine of x is equal to 0. Well, when is cosine equal to 0? Let's take a quick look at a unit circle. You know that the cosine is equal to 0 here at pi over 2, here at, for example, like negative pi over 2, right? Or if I wrap around again at 3 pi over 2 and so on. So whenever x is equal to negative pi over 2, or pi over 2, or x equals 3 pi over 2, and so on, then we're going to have the tangent undefined, and if tangent's undefined, then we're going to have vertical asymptotes. So remember we talked about vertical asymptotes last class. So we're going to have a vertical asymptote at negative pi over 2, and we're going to have vertical asymptote at positive pi over 2 on our graph. If we graph the tangent function and we put in some values, we know that it's undefined at negative pi over 2. It's undefined at positive pi over 2. And what about some of these other ones? What was tangent of 0? If x is equal to 0, let's go back to our unit circle. Let me clear this stuff out for a minute, slide this over here. At 0, the ordered pair here is 1 comma 0, right? So that would be y over the x, right? For tangent would be 0 over 1, and that's equal to 0. Right? 0 over 1 equals 0. So we can actually plot this point right here for tangent. All right, it goes through 0, 0. What about at negative 1? When is the tangent? What if, actually, you know what? I could just add to this, instead of having this, let's make this negative pi over 4 and make this pi over 4 here. And so what happens at negative pi over 4, that would be down here like this. The ordered pair is square root of 2 over 2, negative square root of 2 over 2. So if I take that y over x, I get a negative 1, which would be about here on my graph. So at negative pi over 4, my tangent's negative 1. At positive pi over 4, that would be like up here, for example. That's positive square root of 2 over 2, square root of 2 over 2. And so I end up getting positive 1. At pi over 4. So this is negative pi over 4, it's at negative 1, positive pi over 4, it is positive 1. All right, so our graph is actually going to look like this. It's getting closer and closer to that vertical asymptote, but never reaching it. This one is curving like this, getting closer and closer to that vertical asymptote, but never reaching it. And that whole pattern is going to get repeated every, every how many units? How wide is this? How wide is this pattern? It goes from here all the way to here. What's that width from negative pi over 2 to pi over 2? That width is pi. So the period for the tangent function is going to be pi. All right? Not 2 pi like with sine and cosine and secant and tangent. All right, so let's skip all that good stuff there. But let's get to this. The period we just talked about is pi. And the domain is going to be what? Well, it's going to be all real numbers except those values that we were talking about, except x equaling negative pi over 2, pi over 2, 3 pi over 2, and so on. In other words, it's going to be defined, the domain's going to be defined everywhere except where we have a vertical asymptote. And the range, let's look back at our graph. The range, how far down does the graph go? How far up does the graph? Sure looks like it goes from negative infinity to positive infinity. So that's what we'll say for the range. All right, negative infinity to positive infinity. Okay, so in order to graph, at this point, I think you should pull up the two handouts that you have received. And so we're going to be graphing tangent functions and following some of the steps on there. All right, so let's just start with, number 1 on that sheet. So we are going to graph tangent function. And let's actually look at how the tangent looks on the graph first. So if I go to my calculator and I graph tangent of x, there's that squiggle that we saw. And let's actually do our zoom trig. So menu, window zoom, zoom trig. And that gives me from negative 2 pi over here, right? This is negative 2 pi to positive 2 pi over here. And I see that right here, in between the two patterns, that must be where the negative pi over 2 is. And here we're going to have a vertical asymptote here between those two squiggles, and that must be where positive pi over 2 is. So our graph looks like this, and it just keeps repeating the same squiggle shape, all right, as we go. So let's graph this. Again, the period, and our formula for the period is going to be pi divided by b, not 2 pi over b, right, like in sine and cosine and secant and cosecant. And the asymptotes, as we described, we're going to be at negative pi over 2, pi over 2, 3 pi over 2, and so on. We could get a whole list of it. All right, so there's, this is what you're graphing on your paper. Vertical asymptotes here. We'll have another vertical asymptote at negative 3 pi over 2. So here's how I want you to graph this. I want you to put right in between the middle value here is going to be 0, right? 0, 0. And then this is pi over 4. It's up to a height of 1. That's pi over 4 there. And this is negative pi over 4. And that's, let me move that guy down. I can't do that. This is pi over 4 here. This is negative pi over 4 here. And so I'm going to plot this point, 0, 0, like this. So I do want an accurate graph. Make sure it's curving but not hitting your vertical asymptote. And then do the same thing here. So the middle, right in between the two vertical asymptotes, is a height of 0. Then 1 to the left is negative 1, 1 to the right is positive 1. And it curves like this. So go ahead and draw that shape in. And you're plotting these points as we go. All right, and so at least that's a little bit of the graph. At least that's 3 periods worth. Remember, the period is pi over b, or just pi if our b value is 1. All right, let's get to the good stuff. Let's talk about how to do something where there's some parameters like the a, the b, the c, the d. So we're really trying to graph something of the form like y equals d plus a, whoopsie, y equals d plus a times tangent of bx minus c. A lot of what we're going to do is going to be very similar to what we did for graphing sine and cosine, but some of it is going to be different. So first of all, remember, amplitude means the distance from the midline to the highest point. Well, there is no amplitude if it goes up to positive infinity. So again, this is like a trick. You're going to say none, right? The period is going to be pi over b, not 2 pi over b, right? So in this case, we should put down our a, our b, our c, and our d. All right, so a is 1, b is 3, c is 0, and d is 1. I hope you agree with that. So in this case, it's going to be pi over 3 as our period. All right. Horizontal shift. In order to find that, we're still going to be using c over b as our formula. So we do c over b for the horizontal shift. That is just going to be 0, right? And a vertical shift, we're going to say up 1. All right, so for our starting point, all right, so if we are looking for our starting point, now this is where it gets a little different. The starting point here is going to be found by setting bx minus c not equal to 0, but we want one of our vertical asymptotes. We want to go from one vertical asymptote to another. So it probably makes sense to say, well, let's go from the vertical asymptote of negative pi over 2, and then our ending point, we're going to set bx minus c equal to the next one to the right of that, which would be positive pi over 2. So those are going to be our rules for finding the starting point and the ending point, or at least the starting position and an ending position. So in this case, our bx minus c is really 3x. So I set that equal to negative pi over 2 to get our starting point. This is to get our start. This is going to be to get our ending point. And so at this point, I'm going to multiply both sides by 1/3. And so I'm getting x equals negative pi over 6. So I know my starting point is negative pi over 6. And my ending point, I am going to set, I'm right here, I'm setting bx minus c equal to positive pi over 2. And so I'm going to get 3x equaling positive pi over 2. And again, I want to multiply by 1/3 to both sides. And so I get my ending point is going to be a positive pi over 6. All right? So just like before, I can fill that in my table. I call my first column x. I'm going to start with negative pi over 6 for my starting point. My ending point is positive pi over 6. All right? So let's hold off on the asymptotes for right now, but we do need to have the step. And the step is the same as before. It's going to be period divided by 4. Our period was pi over 3, so I need pi over 3. We need a little bit more work. We need a little bit more room here. So the step is going to be pi over 3 divided by 4. And so that's the same as pi over 3 times 1/4. That gives me pi over 12. So that's the step. So I do want to keep increasing, add pi over 12 each time. Keep adding pi over 12, add pi over 12. And so on. So this is going to give me a negative pi over 12. That's going to get me to 0. That's going to get me to positive pi over 12. And then that'll get me to pi over 6. All right? Okay, so then our next column is just going to be the tangent of bx minus c, or in this case, it's tangent of 3x. Now here's where things also get different. We know that if we go back to our values here, if I was going to graph this with a table, I would put x, I would put negative pi over 2 as my starting point, positive pi over 2 my ending point, and I would advance by my step, which would be pi, is my period, divided by 4. So I would add pi over 4 here and get, negative pi over 4, add pi over 4 and get 0, add pi over 4 and get 1 pi over 4, add pi over 4 and get pi over 2. So then my next column for tangent of x, these are going to be my key values for tangent. Well, I know that negative pi over 2, which is right here, there was a vertical asymptote there, right? So I know it is undefined. All right? It's undefined over here at positive pi over 2. We had vertical asymptotes there as well. So that's undefined. And I know at 0 it was equal to 0. At negative pi over 4, it was negative 1. And at positive pi over 4, it was positive 1. All right, so this right here, these are going to be the key values that you're going to need to memorize for tangent. And this will always be your second column in your chart. Just like for sine, the second column was always 0, 1, 0, negative 1, 0. And for cosine, it was 1, 0, negative 1, 0, 1. Well, for tangent, it's always going to be undefined, negative 1, 0, 1, undefined. So let's pop that in our second column. All right, we're going to say undefined, negative 1, 0, 1, and undefined. All right. Okay, so at this point, we only had one more change to do, and that was plus 1. So I'm going to put tangent of 3x in parentheses plus 1. So I just need to add 1 to each of these values in the second column. Well, undefined plus 1 is still undefined. Right? Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And undefined plus 1 is undefined. So we are really graphing this first column and this second column. All right, so that's what we are plotting on this graph, which I have right here. All right, and I think we're going to want to play around with our increments a little bit because I got a graph like pi over 12s and things like that. So let's make this pi over 12. This would be pi over 6 then, right? 2 pi over 12. 3 pi over 12 is here, but I could really write that as reduce that, and that's pi over 4. This is pi over 6. Then 4 pi over 12 would be pi over 3, and so on. 5 pi over 12, 6 pi over 12 is pi over 2, 7 pi over 12, and this would be 8 pi over 12, which is the same as, what, 2 pi over 3. Okay, and then I would want to change these over on this side also, like this is negative pi over 6, this is negative pi over 3, this is negative pi over 2, this is negative 2 pi over 3. All right, great. So now that we have those chosen and drawn in, I want to have negative pi over 6 be undefined and positive pi over 6 be undefined. So I can pop in my vertical asymptotes at negative pi over 6 and pi over 6. And I can see that at negative pi over 12, I should have a height of 0. So here's negative pi over 12 is right here. I should have a height of 0 there. And then at 0, I should be a height of 1. And then at pi over 12, I should be at a height of 2. And that's good. That's all you really need to plot. But now you got to draw in your curve. Remember, it's got to be curving, getting closer and closer to that vertical asymptote, but never crossing it. So it looks like this. And we basically want to get this same pattern repeated. If I can, I probably can't get that copied too well. But I think we should probably predict where our next vertical asymptote is going to be. We had one at negative pi over 6, and then there was 1, 2, 3, 4 jumps until we got to the next one. So I would like to do that same 4 jumps, if you will. And it looks like I'm going to have my next vertical asymptote here at pi over 2. And I could do those same 4 jumps and then over here, and it looks like at negative pi over 2, there's going to be a vertical asymptote here. All right, and so I can fit this same squiggly shape in, if you will. Whoops, that point's in the wrong spot. That's got to be up here. It looks like these were my points that I wanted to plot, and so the graph is going to look like this here and this here. All right, and I want to do that same thing over here. So I'm going to have this point, this point, this point, and draw in the graph. All right, at least I did 3 complete periods here for this tangent function. All right, there was more that we had to do. So I just listed, or we just talked about where the asymptotes were going to be. So I'd probably say negative pi over 2, negative pi over 6, negative pi over 2, negative pi over 6, positive pi over 6, positive pi over 2, dot, 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 and so on. All right, and, okay. And I think we're good to go on to the next problem. Let's try this one. That looks like the same one. Let's try this one. This is 2 times tangent of x minus pi over 2. So in this case, again, our A, let's list our A, our B, our C, and our D. All right, in this case, our A will be 2, B will be 1, C will be a positive pi over 2, and D is 0. So amplitude, you're not fooling me, there is no amplitude for a tangent function. Period is going to be pi over B, but the B is 1, so it's really just going to be pi. Let's not worry about the horizontal shift for this. Vertical shift, I would say none. All right, starting point, remember that's when we take, I'm going to write starting point over here. Starting point is when we take Bx minus C, and we set it equal to that first vertical asymptote, which is negative pi over 2. And so in this case, we want to do x minus pi over 2 equal to negative pi over 2. We add pi over 2 to both sides, and we get x equals 0. All right? How about the ending vertical asymptote is going to be at Vx minus C equaling a positive pi over 2. So I set x minus pi over 2 equal to a positive pi over 2, and I add pi over 2 to both sides, and I get x equaling pi over 2 plus pi over 2 would be pi. So it looks to me like the starting point is 0, ending point is pi. I could fill those in here, start with an x, put a 0 here, put a pi here. The step is going to be period divided by 4. So in that case, this is going to be pi over 4. And so I just need to advance by pi over 4 each time here, right? So I'm going to have 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, and add pi over 4 one more time, and we do get pi. All right, so step is pi over 4. All right, let's hold off on the asymptotes for a moment, and we're going to fill this in here with the tangent of bx minus c, which in this case is tangent of x minus pi over 2. Remember, this is where we're going to fill in our key values. Get rid of this highlighter, get rid of this highlighter. These are our key values right here, right? Undefined, -1, 0, 1, undefined. So that's what we're going to fill in here. Undefined, -1, 0, 1, undefined. Okay? And so, in this case, our next column is going to be 2 times that. So I need 2 times tangent of x minus pi over 2. And so I need 2 times each of these values. Well, 2 times undefined is still undefined. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. And then undefined. All right. So we're ready to graph this function. So on your paper, we need to put vertical asymptotes wherever it was undefined. And so that looks to me like we're going to have vertical asymptotes at 0 and at pi. All right, so I'm going to fill in vertical asymptote here and vertical asymptote here. I see at pi over 4, which is going to be right here. This is pi over 4, 2 pi over 4, 3 pi over 4. So at pi over 4, I should have a point of -2. At pi over 2, I should be at 0. At 3 pi over 4, I should be at 2. Again, it's a little stretched out, but that's because there's been a vertical stretch. But we want to have our shape looking like that. Again, it looks like in between the 2 vertical asymptotes, it was 1, 2, 3, 4 jumps. So I want to go 4 jumps away over here and get my next vertical asymptote, which is going to be at -pi. And I'm going to fill in that same pattern of points, which looks like it was -2, 0, +2. And so I'm going to fill that in here, and I'm getting a graph that looks something like this. At least that's 2 complete periods worth for this. And if I need to list like 3 consecutive vertical asymptotes, I could say -pi, 0, and pi. So let's fill that in here. -pi, 0, pi, dot, dot, dot. You can say 2 pi, 3 pi, 4 pi, and so on. All right, so that brings up cotangent. All right, cotangent is very similar, but it is a little bit different. The period is still going to be pi, but the asymptotes are going to be in a different spot. Remember, the cotangent comes from cosine of x over sine of x, right? So this time it's going to be, the graph is going to be undefined whenever sine is equal to 0. So thinking back to our unit circle, where is the sine equal to 0? Well, that's over here at 0, right, because the order pair is 1, 0. And over here at pi, because the order pair is -1, 0, right? Whoa. So if I take the x over the y, if I take x over y here, I get 1 over 0 is undefined. If I take -1 over 0 here, I get undefined. So that tells me that I'm going to have vertical asymptotes at 0, and at pi, and again at 2 pi, and again at -pi, and at -2 pi, and so on. These are different vertical asymptotes for cotangent than there were for tangent. But notice they are still pi units apart. So that's why the period is still pi. The period is pi for cotangent and for tangent. All right, and then the key values here for this are going to be still the same. It's still going to be -1, 0, and 1. Because at pi over 2 up here, if I want to find the cotangent of pi over 2, remember the order pair is 0, 1, so I'll have to take the x over the y, and that's 0. 0. That's why I have this point right here. And then if I do negative pi over 4 and pi over 4, I get negative 1 and 1. So I'm filling in the graph like this. Here it is that same, whoa, that's not right. I take it all back. I changed that completely, almost completely. What do I need to fix? What I need to fix is, I still agree that this should be 0. If pi over 2 is 0, we just showed that. I erased it, but we just showed that here, right? But let's talk about pi over 4. Here's pi over 4. The order pair is still square root of 2 over square root of 2. So if I take the x over the y, I'm going to get positive 1. So that should be up here. So that was my bad. So at pi over 4, it is positive 1. But at 3 pi over 4, slow that down a little bit. At 3 pi over 4, it's down here. So here's 3 pi over 4. The order pair here is negative square root of 2 over 2, positive square root of 2 over 2. So if I take the x over the y, I get negative 1. So that graph is going to look like this. It is still a squiggle shape, but this squiggle is a decreasing squiggle as opposed to the tangent one, which is an increasing squiggle. All right, and that squiggle is going to keep repeating every pi unit, so I can pop in my next 3 points here, like this. That's not so good. Oh, goodness. That was not what I wanted to do. Still not what I wanted to do. Let's see. So I'm filling in at 3 pi over 2 is 0, then 1 to the left is positive 1, 1 to the right is negative 1. So that graph is looking like this here and like this here. So at least that's 2 complete periods. Here's 3 complete periods for the cotangent function. All right. If we are going to look at what are the key values here to help us with graphing cotangent functions, let's kind of talk about this. So we're getting our key values for cotangent. We know that it's undefined at 0 and at pi, so I can fill in undefines for those. But then at pi over 4, pi over 2, 3 pi over 4, I'm going to have positive 1, 0, negative 1. So this is going to be, these are going to be the key values for cotangent. Undefined, 1, 0, negative 1, undefined. So the only difference between this and the tangent is these two are switched on tangent and cotangent. So how are you going to remember that? Well, here's a suggestion. I would just fill in, we're graphing cotangent, right? So I would fill in C, O, T, or at least think of that. Wherever the T is where the negative 1 is going to be. So if I go back to our key values for tangent, which I have here, if I spell out tangent, T-A-N, wherever there was a T was our negative 1. So the T for tangent is the negative 1, but the T for cotangent was negative 1. So maybe that'll help you remember. All right, so let's try graphing number 5. We're graphing f of x equaling 1 minus 2 cotangent 4x. No amplitude on a cotangent graph, so we can write none. The period is going to be pi divided by b. Well, let's talk about what's our a, what's our b, what's our c. So a is negative 2 in this case. B looks like 4. There is no c value. And d is a positive 1. So we want pi over 4 as the period. Okay? Let's not worry about horizontal shift. Vertical shift, we're going to say, it looks like it's up 1. All right? To find our starting point here, we're going to need to think differently. This is not the same as tangent. Similar, but not the same. Let's go back to our graph that we just did. Where are these kind of key vertical asymptotes? Well, we have this one here. Some dotted lines here. So I've got this one here at 0, and I've got this one here at pi. And all the action is happening in between these two. So it's this one at 0 and this one at pi. That's going to give us our starting point and our ending point at 0 and at pi. So going back here, we're going to find our starting point for cosine by setting bx minus c equaling 0. And we're going to find our ending point by setting bx minus c equaling pi. By doing that, we're going to find where our vertical asymptote should be. So in this case, the bx minus c is just 4x. So 4x equals 0, and I divide by 4, I still get x equals 0. And if I have 4x equal to pi, and I divide by 4, I get x equals pi over 4. So I know my starting point is 0, ending point is pi over 4. I can fill those values in. Make this, I'm messing things up. I'm trying to make this a little bigger. Okay, let's see. Slide this down a little bit. Okay, so I'm going to start with 0 here, pi over 4 here. I do need my step. Step is still going to be the same period divided by 4. And the period was pi over 4. So if I divide by 4, that means I'm really doing pi over 4 times 1 over 4, which gives me pi over 16. So I'm going to advance by pi over 16 each time. So that's going to give me pi over 16, 2 pi over 16, which would reduce to pi over 8, 3 pi over 16, 4 pi over 16, which reduces to pi over 4. At this point in my next column, I need cotangent of bx minus c. Well, that's cotangent of 4x. What am I filling in this column? That's what we just talked about here. Undefined. 1, 0, negative 1, undefined. Undefined. 1, 0, negative 1, undefined. I can't remember. Was it supposed to be 1, 0, negative 1 or negative 1, 0, 1? Remember, you're spelling out cotangent for this graph. And wherever the t was is where the negative 1 goes. All right? And so at this point, we're going to put in negative 2 times the cotangent of 4x. So I got to multiply all of these guys by a negative 2. So I'm going to have undefined negative 2, 0, positive 2, undefined. I multiplied all of my second column by negative 2. Last step is to add 1, right? Because 1 minus 2 cotangent 4x same as negative 2 cotangent 4x plus 1. So I want negative 2 cotangent 4x plus 1. Add 1 to all of these, and I get undefined, negative 1, 1, 3, undefined. Does that look okay? I hope. All right, and so if we're graphing this, I'm going to change my increments, and let's go by pi over 16s here. So if this is pi over 16, this is 2 pi over 16, which is pi over 8. Here's 3 pi over 16, 4 pi over 16 is pi over 4, and so on. All right, so it looks like this is 5 pi over 16, 6 pi over 16 is, what's 6 pi over 16? That's 3 pi over 8, and then this is going to end up being 7 pi over 16, and then this is going to be 8 pi over 16, which is pi over 2. All right, and I can fill this in over here. At least it looks like that's going to be negative pi over 8, that's going to be negative pi over 4, that's going to be negative 3 pi over 8, and that's going to be negative pi over 2. So drawing in our vertical asymptotes wherever we had undefined. So let's see, let me get those. So I'm going to have vertical asymptotes at 0 and at pi over 4. All right, and I think we can now plot our points. At pi over 16, I should have a point at negative 1, so it's right around there. At pi over 8, it should be a positive 1. And at 3 pi over 16, it should be positive 3. So I'm going to fill in that cotangent squiggle. And you might be like, wait, I thought cotangent was like a decreasing squiggle. This squiggle is increasing. Well, remember, that's because we had a reflection over the x-axis because our a value was negative. It reflected over the x-axis. It looks to me like we could put our next, let's see, how many jumps do we have? 1, 2, 3, 4 jumps. I go 4 jumps over to put my next vertical asymptote, and that would be here at pi over 2. And if I do the same thing over here, I could have another vertical asymptote at negative pi over 4, and I could fill in these values here with those same points. So it looks like negative 1 here, positive 1 here, positive 3 here. Fill in my little squiggles there. I can get rid of that. That's not really part of our graph. And if I do the same thing here, negative 1, positive 1, 3, getting that shape there. So it looks like I plotted like at least 3 periods worth. So if I have to list where my horizontal asymptotes are, I can say they sure look like they are occurring at negative pi over 4, at 0, and at pi over 4. All right, and the step, I didn't write it down, but it should be pi over 16. We talked about that. Okay, so let's move on. We've got one more to go. Let's take a look at this one. And this one, I threw everything at you. There's an A, a B, a C, a D, so let's get that listed first. All right, so the A here is 3, the B here is 2, the C is negative pi over 4, and the D is negative 1. So in this case, there is no amplitude. Right, can't fool me, and the period is going to be, remember, it's pi over b for tangent and cotangent, so that's going to be pi over 2. All right, let's not worry about the horizontal shift. Vertical shift, we're going to say down 1. Okay, and our starting point, remember this is a cotangent graph, so we start by setting bx minus c equal to 0, and we end by setting bx minus c equal to pi, because that's where our vertical asymptotes are on the parent function. All right, so I set my bx minus c is 2x plus pi over 4. So I'm going to set that equal to 0 to get the starting vertical asymptote. I'm going to subtract pi over 4 from both sides. I get 2x equals negative pi over 4. Multiply by 1/2 to both sides, and I get x equals negative pi over 8. And that's going to be my starting vertical asymptote. I wrote starting point, but in this case, it's really a starting vertical asymptote. And then our ending point, we're going to set 2x plus pi over 4 equal to pi. Let's subtract pi over 4 from both sides. So I get 2x equals, oh boy, let's see, that's going to be 4 pi over 4 minus pi over 4. So that looks like 3 pi over 4. And then if I multiply both sides here by 1/2, I think I get that my ending vertical asymptote is going to occur at 3 pi over 8. My ending vertical asymptote or ending point is going to be 3 pi over 8. So I can fill that out in my chart, make that a, whoopsie, that's not what I wanted to do. Let's start with x here, and then negative pi over 8 here, positive 3 pi over 8 here. Let's talk about the step for a minute. Slide this graph down, not ready for this yet. All right, to find the step, I'm going to take the period, which we decided was pi over 2. Period divided by 4. So I want pi over 2 divided by 4, or think of that as 4 over 1. So that's going to be pi over 2 times 1 over 4. So the step is pi over 8. So in this case, I want to keep adding pi over 8 each time. So when I do that, I get 0, pi over 8, 2 pi over 8, which is pi over 4, then 3 pi over 8, all right, and so on. At this point, we're ready for our next column, which is going to be cotangent of the bx minus c. So it's cotangent of 2x plus pi over 4. What goes in that column? That's our key values for cotangent. We have them right here, right? That's undefined. 1, 0, negative 1, undefined. So let's fill those in. All right, when we fill this in, this is undefined, undefined. Let's see, I forgot already. I know there's a 0 in the middle. Does the negative 1 go here, or does the negative 1 go here? How do I decide? Well, I fill in COT for cotangent, because I'm graphing a cotangent. Oh yeah, the t gets the negative 1. So that means this must be a positive 1 here with the c. All right, at this point, I want to do 3 times that. I don't have enough room. I'm just going to write 3 times cotangent. I'm just going to put parentheses there. And so I want 3 times that second column. Well, that's just going to be undefined, 3, 0, negative 3, undefined. All right, and then our last step is to fill in 3 times the cotangent of the 2x plus pi over 4, which I'm not squeezing in there, and then minus 1. So I need to subtract 1 from everything in my third column. Well, undefined minus 1 is still undefined, so I'm going to make that undefined. This is going to be 2, a -1, a -4, and undefined. I think we're ready to graph. So if we're graphing, I see that I have vertical asymptotes wherever I had undefined. So that's going to be -π/8 and a +3π/8. Let's change our increments here. Let's make this like -π/8. This would be 1π/8, 2π/8, which is π/4, 3π/8, 4π/8, which is π/2, 5π/8, 6π/8, which is 3π/4. I think that looks right. 7π/8, and then 8π/8, which is just pi. And I could change a few of these over here so that they match. That's going to be -π/4. That's going to be -π/2. That's a -3π/4. And that's a -pi. So in this case, I'm going to fill in those vertical asymptotes at -π/8 and 3π/8. So, oops, let's get those in here, -π/8 and at 3π/8. Okay? And so at this point, I'm going to plot these points. Let's see, I need 0 going to 2. 0 going to 2. That's going to be right here. And I have, next point to plot is π/8 at -1. π/8 at -1. And then I have π/4 at -4. π/4 is negative, that's about down here, I think. So I'm connecting these with kind of a smoothie, kind of curvy, kind of squiggle line like that. And hopefully you're going to notice again, I got 1, 2, 3, 4 jumps in between the vertical asymptotes. So it looks like I'm going to have my next vertical asymptote at, 7π/8 right here. Okay, and if I do the same thing over here, 4 jumps, 4 jumps, it looks like my next one is going to be at, I didn't write the numbering. What is that going to be? Well, if I go by π/8 here, that's -1π/8, -2π/8, -3π/8, -4π/8. Sure looks like -5π/8 is our next vertical asymptote. So I'm going to just keep repeating this pattern here. It looked like it was up 2, then a -1, then a -4, and I'm connecting these. All right, and then same thing here, going from left to right, it was at a height of 2, then a height of -1, then a height of -4, and connect those. All right, and I can get this little squiggle out of the way. That's not part of our graph. All right, so I graphed 3 complete functions. I see that the period is π/2 units, right? That's what we said the period was. I can fill in some of these horizontal asymptotes that we found. We said -5π/8 would be one of them. -π/8 would be the next consecutive one. Then 3π/8, then 7π/8, comma, ... So I listed 4 of them there. And again, I keep forgetting to write my step in there. So step was π/8. Squeeze that in. All right. And that completes this graph and completes these notes. Thank you so much for watching. Have a great day.